Hello everyone, welcome back to Mr. Lee's Math Class Videos. I'm Mr. Lee. We are now in 7.3 part 4. We had gotten to this point on tangent, but we need to talk a little bit about rationalizing. What I'm going to do is rewrite this equation with the ones going first in both sides to make it consistent. One of the things that we have to do, and your homework will force you to do, is to rationalize the denominator. This is actually the first denominator we've dealt with, which is kind of a conjugate in that it has a real portion and an imaginary portion. Not imaginary, but irrational portion more appropriately, which is similar to dealing with imaginaries because of imaginaries really just represent roots of negative numbers. If you need to clear denominators in some way, first start by clearing the denominators by multiplying everything by 3. That will give you 3 plus root 3 over 3 minus root 3 when it's distributed. That doesn't clear up your square roots, but it at least clears up your fractions inside the fractions. Now, the problem that we have is 3 minus root 3 is irrational. In order to clear an irrational that has two terms, a real and an irrational term, you need to multiply by the conjugate of the denominator. What that means is whatever you see in the denominator, you multiply by the same thing with the opposite sign in the middle, and then you'll have to distribute. What this actually does is in the numerator, we get 3 plus 3 root 3 plus 3 root 3 plus root 3 times root 3 is another, well, this is 9. 9 plus root 3 plus root 3 plus 3. The reason this helps us is in the denominator we get 9 plus 3 root 3 minus 3 root 3 minus 3. So what this actually helps us do is that the irrationals in the denominator will cancel out. Our numerator is now 12 plus 6 root 3. Our denominator is actually, these two cancel, and 9 minus 3 is just 6. Well, these are all multiples of 6. It allows us to reduce it to a nice 2 plus root 3. So now we talked about, for the 15 degrees, 15, 75, 105, 165, 195, everything that's 15 off from a quadrantal, we said sine or cosine generally end up with plus or minus root 6 plus or minus root 2 over 4 at the 15s. Tangent and cotangent are kind of the opposite. And of course, the reciprocals are just flipped when you have secant or cosecant. For cotangent or tangent, you end up plus or minus 2 plus or minus root 3. It's a little bit simpler. All of them will end up in this form some way, where one of these is positive and negative. The other one could also be positive or negative, but it will always involve these numbers when you are using the sum or difference identities. So I just want you to be aware of that when you're doing it. Now, just like we did cosine from right to left afterwards, we also can do sine and tangent from right to left. I'm going to do B and C. So as you can see, you're trying to figure out which formula does this match. Well, if the numerator is plus, the only one it can be is tangent A plus B. So this whole thing is equal to the tangent of 80 plus 55 degrees, which is the tangent of 135 degrees. That is our 45-degree angle in the second quadrant, which is actually, it's negative because of the second quadrant, so this whole thing is just -1. On C, similarly, you see a plus in the middle on a sine formula with alternating. This is sine A cosine B plus cosine A sine B, and you'll notice again, it's the one with the plus in the middle. So this is really equal to the sine of pi over 5 plus 3 pi over 10. If you get a common denominator, that's 2 pi over 10 plus 3 pi over 10, which is 5 pi over 10, which actually reduces to the sine of pi over 2. And the sine of pi over 2 is 1. So it looks complicated, but when you clean it up using the formula, it actually becomes less complicated. And I will leave the other ones, A and D, for you to do. They're very similar in how they operate. What other things have we done with cosine that we can also do with these trig functions? Well, we'll see. The ones for s plus t will come, but the ones that you use, how they operate to find answers, also works. I think we will do, I will leave A and B for you to practice, and I will do C and then talk about D before we probably pause this video and end in the last one. So the tangent of pi minus x. Now the tangent of A minus B is this formula here, tangent A minus tangent B. So it means our numerator is tangent pi minus tangent x over 1 plus tangent pi tangent x. Now why is this useful? Well, the tangent of pi is actually 0. So this leaves us with 0 minus tangent x. And because this is 0, 0 times tangent x is 0 over 1 plus 0, which is negative tangent x over 1, which is actually just negative tangent x. So the tangent of pi minus x is actually equal to the negative tangent of x when you simplify using the identity. Now, why might they ask you if this can be done for the tangent of 270 minus pi? Because you know if you break this down, it would be very similar. Tangent of 270 minus tangent theta over the same thing. But it leads us to a problem. In order to go any further, we'll have to evaluate the tangent of 270 degrees. However, because tangent is y over x, and if you think about the unit circle, we're down here, y over x is tangent, but here our x is 0, so we're dividing by 0. So that means the tangent of 270 degrees is actually undefined. So we cannot come up with an equation for tangent of 270 theta minus, or 270 degrees minus theta, because applying this formula would tell us undefined minus tangent theta over 1 plus undefined times tangent, in this case, theta, which doesn't make any sense. Our trig functions have to be defined at the point in order for us to use them. That's not a problem with sine and cosine because they are defined everywhere. This is tricky when you involve tangent of 90, 270, any of the pi over 2s or multiples of pi over 2 that don't reduce. It won't be possible, so you have to recognize when things can actually be done and when they can be not. Now, I think that will be all for this video. We should be able to wrap this up in the next video, and I'll see you for that.